Humbug. So good afternoon. Thank you very much to those of you who've come today. It's very nice of you to take time out of your calendars. And I hope this will be a stimulating talk. I'd also like to thank those people in the audience who've actually influenced my career over the past. And there's quite a number of them. Felicity Huntingford at the front here, Ali Dingwall, with who works in the seafood industry and has been a real mover and shaker and has been a great source of inspiration and a great collaborator. So just thank you to those people. And Selina Stead at the you sort of in the marine science community, you kind of all grow up together. It's a very small community. And so without those people's support, I don't think I'd be stood here today. So I'd just like to thank them at this point in time. So today I'm going to talk to you about the future of sustainable seafood from wild resources. I'm delighted to have landed in Scotland. Scotland was sort of calling me for many years. It was a much more obvious place for me to be a scientist and do my research. And I always used to look from Wales to Scotland with some envy, actually, at the innovative approach that both the Scottish fishing industry and also the Scottish government took to try and really sort of push the boundaries and do things in a different way and a better way. And it's a very exciting place, and I haven't been disappointed. I've been here now 7 months. I've been really impressed with the way that people want to collaborate and how broadly people think across different disciplines. So going into this talk, I'll eventually get to the very specifics of my own some of my own research interests, which are broad. But what I'm going to do is set some context to wild capture fisheries and seafood. And then I'm going to talk about the specific problems that I've been very focused on for the last 20 years or so. And then finally, I'm going to sort of hopefully touch on some of the potential future innovations which are just starting to emerge now, the possibilities with new technology and some of the really exciting things that Heriot-Watt actually excels in, and I hope to sort of bring together and add to my research. So wild capture fisheries, we think about fishing. Fishing grabs a disproportionate amount of headlines in the media. And someone's going to mention it, so I'll mention Brexit. And fisheries has been very prominent in the Brexit discussion because it's associated with our cultural heritage and our sense of nationhood. And obviously in Scotland, the Scottish industry accounts for 90% of the fish that are landed into the UK. So this is the epicentre of the UK fishing industry, without a doubt. But fishing, wild capture fishing, is subjected to a lot of controversy because of many of the associated environmental impacts. And it's those environmental impacts that my research has tended to focus on. So this is what the current trend looks like for the most recent data from the FAO, the Food and Agriculture Organization of the United Nations. This shows a really interesting pattern of change in where our seafood comes from with time. What you see in the top blue area of the graph is this massive increase in aquaculture production, and there's no sign of that stopping, and that's a good thing because we need to feed a lot of people in the future, and aquaculture is a very efficient way of producing high quality protein and food for people to eat. Despite that, some people, for that reason, actually write off wild capture fisheries, so wild fish that we harvest from the sea. But we're still talking about 80 million tonnes of food and high quality protein landed for people around the world. And the thing that's important is that we ensure that that source of seafood is resilient going into the future, that we can continue to supply that food from that source going forward in the future. And if we think more broadly about where does that seafood come from, well, this global chart shows you the distribution of global catches. So it's a heat map. So the red areas of the map show you the main areas of the global ocean where our wild capture fish come from. And you can see that the areas are all fairly close to the coastline. They're all associated with the shallow continental shelf. So the seas around the UK, we're blessed with a very wide continental shelf, which means it's very productive because it's relatively shallow water. Or alternatively, they're associated with what we term upwelling areas. So off the coast of Namibia, off the coast of South America, where deep waters come up from the deep sea from a depth of maybe 4,000 meters. They're nutrient rich and they fertilize the upper surface waters, and that feeds and drives pelagic fisheries, so fish like anchovies and sardines and pilchards and things like that. So an important take home from this slide is that the majority of world seafood comes from a relatively small part of the world's ocean. So when you see headlines in the media that the entire global ocean is fished and devastated by fishing, it's quite simply not true, because 90% of fish landings come from a relatively constrained part of the world's ocean. And that's actually a good thing, because it means that fishing is not occurring in other parts of the world's ocean. The other reason that wild capture fisheries are important is when we actually take into account poverty. So at a global scale, it's the world's poorest people that include the largest proportion of fish in their diet as their main source of protein. So for all of us sitting in this room, eating fish is a personal or health choice that we make. But if there was no fish for us to eat in Tesco's or Asda or Sainsbury's, there would always be fish in Sainsbury's, of course. If we chose not to eat fish, we have plenty of alternatives. But I remember many years ago having a PhD student from Tonga, and a pig was a luxury, and the main source of protein was fish that they caught from the local coral reef systems. So maintaining sustainable wild capture fisheries is very important for the world's poor, and will continue to be so going forward in the future. So now that's the context. Now I'm going to focus down a little bit more closely on my area of specialism, and that's around a mechanism of fishing called trawling. So why trawling? Well, trawling accounts for 25 million tonnes of those 80 million tonnes of global landing. So it's a very significant part of the world global seafood supply. But trawling is often the technique that actually captures the main headlines in the media. So people like Charles Clover, who writes in the Times, my dear friend George Monbiot, with whom I have regular battles in the Guardian about this, they really hate this fishing technique because of its secondary effects. So the point here is that it's such an important mechanism or methodology of food production that we can't just turn it off overnight, but what we can do is actually think about technological innovations to improve its environmental performance, and think about different approaches to management that might reduce the footprint of that trawl activity. One of the key sort of hotspot crunch areas between conservation and wild capture fisheries is when we start to think about the effect that trawling has on the seabed. So these fishing gears by their nature tend to be very robust, and as they're dragged across the seabed, they scrape organisms off the seabed. So inevitably they change the seabed landscape. And of course, if we have very sensitive communities, for example, like this cold water coral reef in maybe 600 or 800 meters of water, those corals might be up to 1,000 years old. You trawl through that, you reduce it to rubble. Quite clearly it's going to take a long time for that system to recover, if it ever recovers at all. So clearly that's not a desirable outcome, that's something to be avoided. But actually those type of communities are quite rare. So I don't want anybody to actually go away with the idea that the sea floor of the ocean is covered in coral reef like this, if only it were. Most of the sea floor will remove the vulgar nice piece of seafood in the middle. Most of the seafloor actually looks like the brown mud that surrounds it. Pretty boring environment, looks like a boring environment. Exciting if you're a marine biologist like myself, full of holes on the deep sea floor. So the majority of the world ocean habitats look like this, not covered in corals. Nevertheless, that doesn't mean that trawling there is necessary. You can just trawl there with carefree abandon. We still need to think about what the consequences of doing that are. The other thing to bear in mind is that fishing techniques themselves are very diverse. So we have trawls, but we also have what we call passive gears, passive fishing techniques like the set nets that you see up here. Many of you, if you've been to Fife for a day out to Pittenweem, you'll see creels lined up on the quayside. These are what we call static gears. They're not dragged over the seabed to the same extent as trawls, but nevertheless they have their own associated environmental impact. So many people have said, well, we could replace trawling with the use of passive gears, but then we'd have to use a lot of passive gear to replace the fish caught by one trawl. And putting set nets or lots of pots into the ocean comes with other environmental costs. So for example, this shag here, which has been diving to try and steal fish out of the net, has inadvertently become tangled and drowned. And we have entanglements of marine mammals, whales even. So basically, any fishing activity, as soon as humans step into the marine environment, we have a tendency to mess it up or change it to some extent. So we can solve one problem, but we might replace it by another problem. The other thing that's very interesting, I always feel, and this is a very social science thing, is how people actually perceive the effects of the fishing and how they don't actually make the direct comparison to the effects of land food production. So I always thought this was quite interesting. So here we have a stamp, which is quite clearly, this is a Canadian stamp, I think, and it's quite clearly celebrating the wonderful sort of breadbasket of North America. You know, these huge prairies where they're sort of cultivating vast landscapes with a monoculture of corn. That's a highly altered, industrialized food production landscape. And yet that's being celebrated. And yet here we have a satellite photo image that appeared in Nature magazine, I think, of Chinese fishing vessels. You can actually see them all lined up as the little dots. They look like the red arrows, but in the sea, fishing. Each one has a little sediment plume created behind it. And you can see that the sediment plumes have actually merged. There's so much fishing activity occurring here. And clearly that fishing activity is creating a lot of change in that environment. There's no two ways about it. But it is producing food, and it continues to produce food. And on the other side of the coin, the other thing that's not happening in this part of the slide in the marine ocean, but is happening over here, is there's no pesticides here. There's no inputs of fertilizers. Those natural systems are actually driven by natural processes. So I always think it's very interesting that when we talk about the sea, the kind of conservation issues seem to be a lot hotter than when we talk about terrestrial land food production. You know, we're very comfortable about talking about set aside and biodiversity schemes and schemes to promote pollinators, and yet we have a very different approach to the way we view the ocean. So, coming to the crux of the science that I've been doing for the last 20 years, here is the problem. So I've drawn for you a cartoon of a trawler, and the trawler is towing an otter trawl, and it's called an otter trawl because it has these two doors which hold the mouth of the net open, and the net's dragged behind those doors. And that trawl is being fished over a muddy piece of seabed, like we saw before, and they're trying to catch the animal that was in the middle of the slide I showed you before, which is a scampi, or a Norway lobster. And this is a picture of the seabed off Sellafield in the Irish Sea. It's probably one of the most intensively fished bits of seabed I've ever seen. So that sort of roughness on the seabed there, that looks like someone's thrown a plate of spaghetti on the floor. That's the crisscrossed matrix of trawl tracks in the mud sea floor. And that piece of seabed has been fished completely 18 times over, and yet it still continues to produce nephrops. Now, it's fortuitous that the nephrops actually live deep in burrows within the mud, so they are able to escape from the effects of trawling. But trawling, of course, with that level of intensity undoubtedly has changed that marine ecosystem. It certainly has. There are species which no longer can survive in that muddy environment unless we remove the trawling from that area. So we can actually see the physical effects of trawling on our seafloor environment. Now, off the coast of Sellafield, we anticipate that the recovery timescale, if you remove trawling, would be about 3 to 4, maybe 5 years at most. The scenario when we go into the deep sea, and deep sea trawls now can be fished down to 1,500 metres. So that's almost a mile, a vertical mile down. It's not far off. And in those deep sea environments, animals live at a much slower pace of life. Everything happens much more slowly. Now this is an image of showing satellite recorded tracks of trawls over a deep sea canyon. So you can see the deep sea canyon as that big sort of tear in the grey landscape going up to the coast of Spain just off Barcelona. And at a depth of about 400 metres, you can see where the fishing boats have all lined up. So that's the yellow speckly patterns. You can see how the fishing boats are all fishing at this depth of around about 300 to 400 metres. And as they trawl the shoulders of these deep sea canyons, they knock mud off the sides of the deep sea canyons, and that cascades down into the deep sea canyon, causing submarine landslides. And of course, those submarine landslides bury the animals at the base of the canyon. Now, those landslides happen naturally, but they don't happen with the frequency that actually occurs when we have trawling in this environment. And the recoverability of those systems is going to be far less, for example, than in more shallow seas. So the effects of trawling vary very considerably depending on the type of trawl you use and depending on where you actually do the trawling. So in terms of our thinking about sustainability, there's a gradient of sustainability and a gradient of timescales over which these activities can be sustained. In contrast to that then, so I bring you back to my home until recently in Wales. This is a picture of the seabed again, this time off in Cardigan Bay, which is very shallow. It's only about 30 metres deep. And what you see is the natural seabed over here with these large mega ripple formations. These are sort of sand dunes, sand waves on the seabed about this high from the seabed. And those sand dunes are formed by natural processes, so tides, currents and storms. And then the scallop fishing fleet have gone in with dredges, and you can see how they've raked out those sand wave formations and they've flattened them out. But the natural processes there in that environment, they're so energetic that those sand waves will be reformed within a period of weeks, maybe months at the most, and the animals that lived there previously will have recovered after a year. The animals that live in that environment are adapted to a lot of disturbance, so they can cope with the additional disturbance that we add from fishing. So fishing in that environment is much more sustainable. This habitat can tolerate a lot more fishing than the deep sea environment I showed you before. Some people didn't believe me about this and criticised me, but I mean this slide shows just how dynamic that seabed is. That is that seabed on the seafront at Aberystwyth after a winter storm, and actually had I turned to the left, most of that beach was in the living quarters of the students who live on the seafront. So they couldn't use those student residences for some considerable time until they got dug out and pumped out as well. So in order to try and understand the process of how trawls change the marine environment, and more importantly to think about how we can calculate the sustainability of trawling in the context of the variety of different habitats that occur in the world's seabeds, requires an international group. So here's an international group I prepared earlier, with which I've been working for about 8 years now. Scientists from New Zealand, America, Australia, Argentina, Holland, drawn from all over the globe, all of whom work in this field. And we set out to answer 5 key questions. Where does trawling occur? That's the most simple question, but it's fundamentally really important and has only been enabled with the advance in satellite technology and tracking technologies that have been employed since about 1996, but are now commonly in use. What does trawling kill? What animals get killed? Which animals don't get killed by trawling? And what moderates this? So are some animals more vulnerable to being killed by trawls than others? And how quickly do they recover? Can we develop a method to do a risk assessment for a habitat? So before any trawling, so think about the Arctic. The Arctic, this is an exciting area. The Arctic's about to be uncovered fairly soon. And so that's opening up the possibility of exploitation of fisheries resources. Wouldn't it be nice to actually do things properly and actually do an assessment before we go fishing there, just to actually understand what level of fishing might be sustainable before we just go marching in and get on with it? What does fishing affect fish production? So the fishing activity itself could actually limit the growth rate of fish. If we're changing animal communities on the seabed, many fish eat the animals on the seabed. So if you're altering the food resource for the fish, could that then be having a negative feedback through to fisheries production itself? And then ultimately, can we actually turn that complex scientific advice into meaningful policy practice? So for the purpose of this research, we talk about trawls. So those of you who know what a trawl is, you'll be more familiar with trawls like that beam trawl, maybe less familiar with these scallop dredges, otter trawls, another beam trawl, a shrimp trawl here. Wide variety of gears are captured in this, fishing gears are captured in this definition. And we try to answer this first question, what is the footprint of trawling? So how did we do that? With our international team, we managed to get the satellite data for fishing vessels for 24 large marine areas around the globe. Now, this is a really difficult thing to do because this data is often confidential and commercially very sensitive. So a lot of governments obviously don't want to share it. We did ask Russia, but we haven't had the data yet. I look forward to receiving it at some point. The other key thing is how we actually display and interpret this data. Now, there was a paper recently that was published in Science magazine, which is very prestigious, which used the figures on the left-hand side of the chart here. And they concluded that over 50% of the world's oceans was affected by trawling and other types of fishing. But we actually had the raw data for these areas. So this is actually what the real footprint of fishing is. What they'd done in that paper was that they'd aggregated up records of fishing activity at a much larger spatial scale. What happens then is you paint out large areas of the sea and you come up with these very dramatic headline statistics. Science and the academic process tends to push us towards sensational headlines. I'm not one for sensational headlines. I prefer to stick with the facts. And the fact of the matter is that the published estimate in that paper was actually between 5 and 10 times larger than the real footprint. So this is the actual data projected at its highest resolution. And you can see that the footprint in those blue areas is far, far lower. And that's very important. If it really was the case that this was the true footprint of fishing, I really think we wouldn't be landing 80 million tonnes of fish today. We'd have an environmental catastrophe on our hands. So that's important to understand that footprint because it also tells us where those environmental impacts occur. The other thing that's really usefully comes out of this is that in areas of the world where fisheries are well managed and there's good scientific information, controlling the amount of fishing activity and having good fish stock management actually shrinks the footprint of fishing because the fish stocks are larger, so the fishing industry can catch the quota of fish in a much shorter period of time, and if you're reducing the time you spend at sea, you're affecting the environment to a lesser extent because we're interfering for a smaller proportion of time. The countries that are doing really well in this are the US, Canada. So these pie charts are for all those areas that we had that satellite data for, and the green area of the pie chart shows you the area of the sea that is not fished by trawls. That's the key statistic. And you can see for North America, for Australia and for New Zealand, and also for South Africa, where we have good, strong, robust fisheries management, that large areas are not fished. When we go to Europe, it's quite different, and actually the worst location was the Adriatic. That is very heavily fished, very intensively fished, a highly modified marine system. Around the UK, it's sort of a mixed picture, but of course we've had a long history of very intensive fishing activity, yet our fisheries still manage to be productive. But it does raise the question that if we were able to shrink that fishing footprint, would our fisheries be more productive in the future? Now, then we wanted to ask the second question, which is, when you trawl on the seabed, what gets killed? That's the key thing. And the way we did that was to look around all the studies that have been done in the world, and we do what we term a meta-analysis, which is the technique that they use in medical sciences, the Cochrane Foundation. Occasionally, if you ever listen to Radio 4, you'll hear that there's new evidence around, say, the MMR jab, for example, and that evidence will have been drawn out of the scientific literature and is subject to systematic review and meta-analysis. So we applied the medical sciences approach to the literature. on trawl impact studies, and there are two types of these studies. So initially, when I cut my teeth as a scientist, we didn't know anything, so we had to do experiments, large-scale experiments where we went out with research vessels and we deliberately trawled the seabed and then measured very accurately what the consequence of that was. But nowadays, because we can build these maps of where the fishing fleet has fished, the fishermen generate for us a natural gradient of fishing disturbance, which we can exploit if we check for, for habitat parameters, so that we're looking across similar types of habitats. If we have a gradient of fishing disturbance, we can then go and see which animals can survive in those different areas and establish a relationship. And what that shows us very clearly is for the different types of fishing gears, they have very different impacts. So for example, at the top, otter trawling is quite kind to the marine environment. So this graph, it shows you the decrease in the amount of animals on the seabed as you increase the intensity of trawling. So this is on this axis here, we're increasing the intensity of trawling, more and more trawling as we go this way. And you can see the number of animals is declining and declining. So for scallop dredging, that decline is steepest. Okay, so this is why I said before, scallop dredging has the most intensive impact on the seabed per unit area fished. Otter trawling the least, and beam trawling is somewhere between the two. Beam trawling, so you're aware, if you like eating Dover soles and plaice, that's what you use a beam trawl to catch. Otter trawling, if you like eating haddock and cod, that's what you tend to catch your haddock and cod with. And scallop dredging, as the name suggests, that's for your scallops. When we look across all those studies, we can start to pull out some interesting results. So for example, not all animals respond in the same way. Some are more sensitive than others. So here's a graph just showing you the degree to which different types of animals like worms or sea anemones or crabs respond to being trawled. So if it's in the red zone, they've declined. If it's in the blue zone, they've increased. Nothing increases. I'm afraid it's just a story of death. But the key thing is how quickly those animals recover afterwards. So in the same way, if you think about a farmer ploughing a field, inevitably a lot of earthworms are going to get sliced in two. But the system doesn't stop, functioning necessarily. It might not function quite as well for a while. The earthworm population will recover at some point. The other thing that came out of this study was a relationship between the way in which the fishing gears interact with the sea floor. So the deeper they penetrate the sea floor, the more animals they kill. Now you might say, well, that's pretty obvious, isn't it? But actually, unless you have a nice relationship like this, you can't make any predictions about what the consequences of different types of fishing will be. So there's the problems. We've quantified what happens. What about potential solutions going forward, and what are the innovations which are coming up? So I'm going to sort of broaden out a little bit here. But I'm just going to stay with the trawling problem for one more slide or two. So we saw before beam trawls, which we catch Dover soles and plaice with. Beam trawls, not very popular in the conservation media. Could we actually modify beam trawls so they have a lighter touch on the seabed? And so one of the groups that I chair in Holland is the electric pulse fishing project. And the idea in the electric pulse fishing project is to get rid of all those chains hanging off that fishing gear, which mean it weighs about 10 tons in air. It's very heavy. If you can replace all of that horrible ironmongery with electric stimulation, which has a much lighter contact with the seabed, could you reduce the penetration depth into the seabed and thereby reduce the amount of animals killed? So that's showing us what a normal beam trawl kills, and actually if we look at the penetration depth for the electric pulse trawl, that's the improvement in death rate we would get. The blue arrow, that's where our death rate would be reduced to by using a pulse trawl. That's the sort of evidence that policymakers want. Clearly the European Parliament didn't want that because they banned the use of pulse trawls, but that's another story for another day. So that's an interesting debate about social media and things like that. The other alternative is, could we use spatial closures? So could we just close bits of the seabed to fishing and have them as sort of pristine areas, marine protected areas? And could those contribute to fisheries productivity? Well, sometimes unforeseen things can happen. So this was a big marine reserve set up off the coast of Holland, and it was designed to protect place, flatfish. And what happened was the fishing industry, all the large vessels, fished right up along the edge of the marine protected area because they thought all these big fish would be swimming out and they would catch them all. Now what actually happened was, with all that intense fishing, they changed the landscape in a way that made it better habitat for worms like this. And guess what plaice like to eat? Worms. So what actually happened was all the juvenile plaice, not all of them, but a large proportion of them, moved out of the marine protected area to feed on this field of worms. And of course, then suddenly the bycatches of juvenile plaice in the trawl catches went through the roof, which was not a desirable outcome. And it was something that nobody had anticipated. So sometimes these management measures can misfire on us. Marine protected areas, though, can have some really strong beneficial effects. This is a system off Devon, which I worked with several PhD students. And it's a natural marine reserve experiment created by the fishing industry. This is what we call a voluntary closure management regime, where basically in the blue areas you have pot fishermen who are fishing for crabs and lobsters, and trawls and scallop dredges are excluded from those areas. And what that means is that we're able to look to see how the environment has changed. And also this area is huge. It's 350 square kilometres in area. And so the other question we were interested to ask was, okay, this stops fishermen having conflict with each other over the use of space, but does it benefit fish communities? And the way we did that was we looked into recreational angler records. So if any of you are sea anglers like myself, unlike me, you might have caught a decent fish worth catching. My wife will tell you I never come home with anything. But if you do catch something worth holding in front of a camera, we tend to be quite vain, like to take photos of them and post them on social media, or report them in angling magazines. So I had my students actually dredge all the data from years and years and years, going back to 1974, for, in this case, I'm just showing you here two species of ray, or skate as you might know them. One is a short-lived species, the spotted ray up there. The other one is a long-lived species, the blonde ray. And what these graphs show you is in the vicinity of that big protected area, the spotted rays, the weight of spotted rays stayed very high in angling catches. And that means that that area was having a big effect, positive effect in terms of protection. Whereas in the areas outside where there was no protection, then the spotted ray population and the mean weight was declining. However, for the long-lived species, the blonde ray, which is not sexually mature until it's about 9 years old, it declined irrespective of the protected area. And that tells us something really important. It tells us that for long-lived species, if we're going to give them protection, we need very large areas for protection to be effective. The other thing that we found within those areas where there was no scallop dredging is that the scallops of the same size actually were in better condition. So they hadn't been bashed around by trawl gear and scallop dredges. And so when you opened them up, their reproductive organs were actually larger in size. So their potential to produce more eggs and spat was 25% greater than for scallops on typical fishery gowns. So now it's very interesting at this point in time, the fishing industry now are seriously talking about and understanding the value of having broodstock areas for scallops, which can then produce all this progeny that then goes out onto commercial fishing grounds. One of the other problems with trawl gear in particular is that they can be a little bit unselective because of the nature of the fish that go into the net. And sometimes we catch fish which we don't want to catch. This is called bycatch. And it's going to create a real problem for the UK fishing industry at present because of the EU landings obligation, which means they have to land everything that is a quota species. The particular fish in these two images is particularly sensitive. This is a spur dog, it's a small shark. It isn't sexually mature until it's 35 years old. Poor spur dog, I wouldn't like to wait that long. So it's highly sensitive to overexploitation. Now what we were doing here, the fishing industry have been fitting square mesh panels in their net to enhance the escapement of fish through them for many years now, and sometimes they work and sometimes they don't. But now with LED light technology, and because it's so cheap and battery life is so long, the fishing industry has now been experimenting with the use of light. And different fish species respond to different coloured lights. That's interesting in its own right. And some of them respond to strobing lights and some of them just constant illumination. And there's a nice video at this Twitter link where you can watch this spur dog emerging through the square mesh panel, swimming away and coming back round to investigate the light. So literally the light is showing the way through the escape panel. So this is a quite exciting, simple technology, but exciting. The other thing that's, again, a bit of a game changer is miniaturization. So miniaturization in camera technology and also the cheapness of cameras now, like GoPros. These are throwaway items. To build this thing on this diagram here would have cost about £10,000 when I started out. Now I can put a GoPro in this box, and if the fisherman breaks it, I can throw it away. It's so cheap. So what we've been doing in Wales was trying to set up what we call a sentinel scientific fleet of fishing vessels, where they put these cameras on the vessel, and as the fisherman is removing his catch from taking his crabs and lobsters out of his pots, he passes them under the camera. And because we fit the cameras with a laser, we can scale the size of the crab and the lobster. This is what they look like, and they're designed to be cheap and fitted to small inshore boats. So there's also a really important application globally of this technology, because most of the world's fishing vessels are small, often, a dugout canoe or something like that. And these fisheries tend to be very data poor, so we can't do science when we don't have data. And this is what it looks like. Basically, you get a nice video of the catch, the fisherman himself is recording it, and most importantly of all, there's a big on-off button on the side, so if the fisherman doesn't want to record, he turns it off. And that's what gives you social engagement with the fishing industry. And more importantly, they're collecting the data, so they believe it. The next step in the process is to take those images and apply artificial intelligence and machine vision learning and actually turn those images into data automatically. At the moment, that's the rate limiting step. At the moment, I have to get volunteer students to analyze these images. Does it work? Yes, it does. It's better than having a seasick observer on board a boat. This is accurate to within 2 millimeters. Very high, more than adequate for the purpose of science. And then finally, I'm going to finish on another different type of innovation, which is changing the way we manage our fisheries. So apologies to David Donnan in the audience, he's seen this before earlier today. So one of the areas that I was providing fisheries science and advice to the Isle of Man government, again on scallop fisheries. And the Isle of Man government introduced a very innovative management regime known as a territorial use rights system. And they introduced it in a small bay, so it was like a management experiment. Small bay called Ramsey Bay, which is facing the coast of Cumbria and the Solway. And they introduced basically a conservation zone, which was designed to promote conservation of marine biodiversity, but they included within it a fishery management zone, and the purpose of that was to have fishing activity in there. So that's the whole marine management system up there, and this is the fishery management zone here blown up. And what's happened is, because the government gave the fishermen the lease, they gave them the ownership rights to the scallops on the seabed. And once you give fishermen ownership, it completely changes the way they behave. And so they started working, but cooperatively. They also had responsibility for choosing how they fished. So interestingly, instead of all the boats going in and fishing for the scallops, they just sent 2 vessels in. So straight away, they reduced their carbon footprint, and they saved a lot of money in terms of fuel. And they also reduced the amount of seabed disturbance that they created. And the efficiency of that management system absolutely outperforms current commercial scallop fisheries on every single metric you can possibly think of. So this is basically the before and after story for the innovative management regime here, and the open, what we call the open, this is status quo, this is normal fishing behavior over here. With time, over time, these are the same periods of time. And what we see is that the landings, the amount of scallops that the boats are catching per hour fished, per dredge, massively increases after that fishery was reopened, and it's been maintained extremely well. There's another 2 years of data, and it's not going down. It's actually maintained at a constant level. But more importantly, the environmental footprint in terms of fuel burnt to catch and land that protein is extremely low and way outperforms the actual commercial fishing industry outside. In other words, the fishermen are more profitable when they fish there. What that translates through to is something that we call energy return on investment. So how much edible protein do we produce for the amount of fuel burned? Let's put that in some context. And this is my last slide, you'd be delighted to know before the wine. If we compare that management system and the production of scallops, you get an EROI of 0.76, which is far higher than for beef, egg, or pig production. And these are highly sophisticated, very intensive protein production systems. So what that shows us is that it is possible for us, even with one of the more environmentally damaging fishing gears, if we have the management system properly configured and people properly engaged and empowered, can be an extremely productive and sustainable method of food production. And that's the interesting part in the current discussion in Scotland and the wider UK. Can we apply these more novel approaches to management to greatly improve our environmental performance going forward in the future? Thank you very much.